All right, let's take a look at 7.2, operations on decimals. And when we're talking about operations, we are talking about addition, subtraction, multiplication, and division. So let's start off with adding and subtracting. And the main idea, we've talked about it before, is we want to always combine like terms. And terms, remember, are what we call the items that we are adding and subtracting. So first of all, let's take a look at our first method, which is a concrete model. So of course, if it's a concrete model, you want the students to be able to hold things that are tangible. So let's take a look at blocks, flats, longs or rods, and units. Last section, we talked about how we can represent a decimal or a mixed number using these. So let's practice. Right? First example I would show to the students, have them have numbers that go to the same place value. So for example, let's say we're asking 3 4/10 added to 2 1/10. So before we get started, since they're both going to the tenths as the smallest unit of measure, we're going to declare that the smallest unit is the 1/10, has a value of 1/10. And then from there, we just keep assigning the units, longs, flats, and blocks by however many place values. So now our ones unit, our ones place value, will be represented by longs. So let's take a look at these. Again, this is base 10. So if I have 3 longs, and each of these are divided into 10 sections, and I also have 4 units, I want to add to that 2 longs and 1 unit. So by combining like terms, when I combine these together, I'm going to end up with 3 longs added with these 2 longs, 4 units combined with this 1 unit. And this is going to give us a total of 5 longs and 5 units. I didn't draw the pictures this time. And so we end up with 5 longs. Longs represent ones. So I have 5 ones and 5/10 when we're finished. Okay. Then I would probably move to an example that has different place values. So let's say, for example, we are looking at 2.32 added to 1.4. So 2 32/100 added with 1 4/10. Again, start with the smallest unit of measure. Here I go out to the hundredths place. Here, of course, I could always put a 0 in that place, and I'm at the hundredths place. So the smallest unit of measure is 1/100. Then we're going to let the longs represent the next largest, which is 1/10. That takes us to here. But we also need to get to the ones column. Ones will represent, whoops, sorry, wrong way. Flats, unit long flats will represent the ones column. Okay, so this is going to lead us into, let's see, I have two longs. Nope. Let's start over. Sorry about that. I have two whole numbers, 2, 1. So I have two flats. I have 3 longs because that's my tens column. And I have 2 100ths. So that's my 2 units. And I'm going to add to that, here I'll switch colors. I'll put this one in green. I'm going to add to that 1 4 longs and no units. So that leaves us a total of 2 units, 1 2 3 4 5 6 7 longs. I'm just going to do it this way. And 1 2 3 flats. So since flats represent 1, this gives me 3 and 1/10, 1 100th. So it looks like 72 100ths. Okay. So I also want to take a look at what if we have, let's take a look at this one. 12 and 37 hundredths plus 4 and 9/10. Since we're still using concrete models, we haven't gotten to any shortcuts. I would recommend, since this goes 37 hundredths, make sure this other decimal also goes to the hundredths column. So we have 9/10 and 0 hundredths. So now we know what our smallest measurement, the unit, is going to represent. It's going to represent our smallest place value of 1 100th. Then our longs or rods will be in the tenths column. Our flats will be in the ones column. And since we have the number 12, that's 2 ones and 1/10. So we need to go one more. So blocks will represent the tens column. So I'll do this off to the side. 12.37 would look like 1 block, 2 flats, 3 longs, all base 10, and 7 units. And then if I take the number 4 and 9/10, well, I can look at this going, well, I don't have any tens, so I have no blocks. I have 4 flats, 9 longs, and no units. So when we find and add this together, this leaves us with 1 block, 1 2 3 4 5 6 longs, 6 flats, but now take a look, we have a whole lot of longs. In fact, we have 3 6 9 12 of them. So I can rebundle, I can regroup 10 of these and carry them or rebundle them and create one more flat. Which leaves us with 2 longs left over and the same 7 units we had before. So that leaves us with, remember, blocks are 10s, 1s. So we have 1 block, 7 flats, 2 longs, 7 units. And remembering that the 10s, 1s, there's our whole number part. And then we have our decimal part. Okay. All right. Now, before we move on to a different method, let's look at a subtraction problem or two. Keeping in mind that sometimes we will have to rebundle or borrow, regroup them if we don't have enough. So let's take a look at maybe 2. We'll see how many examples we need. So, well, let's just kind of jump right in. Let's say, for example, we want the difference between 13 and 45 hundredths and 1 and 16 hundredths. So again, place value is the same. They both go out to the hundredths column. So we start there. Let our smallest unit, our little tiny cube, be 1/100th. Each long will represent the next place value of 1/10. Each flat will represent the ones column. And each block will represent the tens column. And of course, if we go larger, we don't have anything in 4 dimensions, but we could just represent it. So I could do that. When in doubt, first one I'm going to draw it out. So 1345 gives me 1 block. And 3 flats. Four longs. And 5 units. So this is the number 13 and 45 hundredths. Now I want to subtract from that 1 and 16 hundredths. So that's no blocks, 1 flat, 1 long, and 6 units. Well, if I think about subtraction or taking away or removing, we have a problem in that we have 6 units and we're supposed to remove them from 5, so I don't have enough. So I'm going to rebundle, I'm going to borrow, and I'm going to rename this 1 long 10 units. Okay, so I had to rebundle, remove, change. Now when we go to subtract, I want to remove 6 of them. Okay, so these 6 are going to be removed right there. They're going to cancel each other out. And by doing that, I now have a total of 2, 4, 6, 8, 9. I'm just going to write 9 of these. 9 units. 1, 2, 3 longs are left. Subtract 2, so I have 2 longs. 3 flats, subtract 1. I have 2 flats. 1, subtract nothing. I have 1 block. A block is worth 10. A flat is worth 1. And 2/10 and 9 hundredths. So I get a final difference of 12 and 29 hundredths. So the first method I always recommend is, some sort of concrete method. We just have to redefine what the units are. A second method is by using the commutative property. Now, you know what? I'm going to do this method, lining up the decimals, so combining like terms. Combine like terms by aligning the decimals. That way, you have your tens, you have your ones column, you have your decimal, then you have your 10th column, you have your 100th column, etc. in both directions. So for example, if we have 14 and 25 hundredths added to 7 and 9 tenths, if we align these vertically, 14 and 25 hundredths, always line up the decimal point. So this would be 7 whole units and 9 tenths. And again, the first time I would do this with a student with adding or subtracting, once I've aligned the decimal points, I would make sure they have the same number of digits. So if this one goes out to the hundredths column, insert a 0 as a placeholder and have that also go out to the hundredths column. And now we can go ahead and add. 5 and 0 give me 5 hundredths. 2 and 9 give me 11 tenths. So I'm going to have 1 left over, rebundle, carry. So give me a 12 carry, give me a 2. And there we have it, 22 and 15 hundredths. So I'm thinking one example is fine there. Same with subtraction. Let's say I have a 235.018 and I want to subtract 17 and 23 hundredths. Lining up the whole units, making sure they have the same number of place values, and let us begin. 8 minus 0 is 8. 1 minus 3, we have a problem. I don't have enough. I can't borrow, so I have to go to the next column. I'm going to borrow 10 from the ones column. That's going to make this a 10. Now I can borrow one of these and turn it into 9, and I've borrowed 10, making that an 11. Now I have 11 units less 8, less 3 is 8. 9 units less 2 is 7. Keeping your equal sign, your and lined up. Again, don't have enough, so I'm going to borrow. Borrowing 10 because it's base 10. And I believe you should get 217 and 788 thousandths. So that's pretty much considered the standard method. That's our standard method, combining like terms. This is a standard. Nowadays, sometimes it's called the old school method. And then our third method, again, always keeping in mind combining like terms. Our third method uses the commutative and associative properties. We want to move, so we're going to use the commutative property to move like terms near each other. And we're going to use the associative properties so that we can group the like terms together. I'm trying to decide which one of these I'd like to do. Okay, let's look at one. Here's an example. 1 and 47 hundredths added to 3 and 81 hundredths. So let's first start with what we have here. Literally, if we break it down to place value, I have one whole number, we have 4/10, and then we have 7/100. Again, break it down to place value. Remembering if there's a 0, put the 0 in there. This is 3 whole units plus 8/10 plus 1/100. So now let's move them around and group them according to their like terms. So I'm going to put the whole numbers together, 1 and 3. Then we're going to move and group the tenths columns together, 4/10 and 8/10. Then we're going to move and group 7/100 added to 1/100. This gives us a total of 4. Now I can combine like terms because the denominators are the same. It gives me 12/10 and 8/100. And then you might notice, well, 12/10 is improper. So this is the same as saying 1 and 2/10. So now what we can do is we can say, all right, now let's combine the whole numbers together. So I have a 5 and a 1 gives me a 6. Now I have 2/10 and 8/100. So that leaves me with 6 and 2/8. Sorry, 6 and 28/100 left over. Hold on, I made a mistake, you probably caught it. Mentally, I already added these together. This should be a 4. That's 1, so this should be a 5. Sorry about that. You probably caught that. That's why I went back and checked. Okay, sorry about that. 5 and 28/100. Okay, now another way to do it, same method, different way of thinking, because everybody thinks about it differently, is it could go well. Now to work with subtraction as well, let's do that first. Let me do a subtraction problem. Let's say I have 5 and 82/100 minus 2 and 1/100. Combining like terms, I'm going to have 5 and 8/10 and 2/100. And then I'm going to subtract 2 and I'm going to go ahead and put it in 0/10 and 1/100 so I don't forget about it. Okay, now we have to remember with the subtraction, we're subtracting everything. We're subtracting the 2 and we're subtracting the 1/100. So I'm going to actually distribute that minus to all of them. So if I regroup and move, the whole numbers are going to be 5 minus 2. Then I'm going to add to that the tenths, which are 8/10. I'm going to be literal, minus 0/10. And then I'm going to combine and add the 2/100. Minus the 1/100. So with subtraction, you have to subtract all the place values. 5 minus 2 gives us a solid 3. 8/10 minus no tenths gives us 8/10. 2/100 minus 1/100 gives us 1/100. So we are left with 3 and 81/100. Or an alternative to this, some might like it that way, some might like it this way. Let's say, for example, I have 2 and 32 100ths plus 1 and 54 100ths. So I could go, well, you know what? This last place value is in the hundredths column, so I can just read straight across and go, this is 232 hundredths. That's an improper fraction, which would reduce out to 2 and 32 hundredths. I can do the same thing here. The last column is again in the hundredths column. So if I read straight across, I have 154 hundredths. Well, if I add those together, I get 386 hundredths. Okay. Which can reduce to 3 and 86 hundredths, which is 3.86. Same idea with subtraction. I'll put it right here next to it. Let's say I just subtract the same numbers. 2 and 32 hundredths minus 1 and 54 hundredths. Again, I'm in the hundredths column, so 232 hundredths minus 154 hundredths. What is that? 232 minus 154 gives us, I gotta borrow. That gives me 8. Gotta borrow again. 12 minus 5 is 7. So that gives me 78 hundredths, or 0 whole numbers and 78 hundredths. Okay. So it's nice to always offer different ways instead of the old standard algorithm. Eventually, once I understand the concept, we can go through and show them the shortcuts. But ultimately, always it's our responsibility to show them many, many, many different ways. So now that we've looked at adding and subtracting, let's look at multiplication and division. Okay, so on multiplication, we really only have a standard method. Let's take a look. The first one is your traditional standard method. So if I give you 1.43 and we want to multiply by 6.2, we do not need to multiply, we do not need to line up the decimals because they're not terms. They're not like terms. And so we can do this the same way we did earlier with whole number multiplication. And go ahead and start with our units. 2 times 3 is 6 units. 2 times 4 is 8. 2 times 1 is 1. No, it's not. 2 times 1 is 2. Now we've used up that place value, so we insert a 0. 6 times 3 is 18. 6 times 4 is 24, plus that 1 that we carried over is 25. 6 times 1 plus 2 is 8. And when we go ahead and add these up in a traditional manner, we should end up with 8866. And now the question becomes, where do we put the decimal? Well, think about your place value. Place value. Here, your place value is in the hundredths column. This second factor has a place value in the tenths column. So if I were to multiply 1/100th times 1/10, I'm going to end up getting 1/1000th, which means we have to put our place value so that we have tenths, hundredths, thousandths. So our final answer has to be in terms of thousandths because we multiplied something that was in the hundredths column times something that was in the tenths column, and that gave us an answer of something in the thousandths column. So I need to place the decimal where I end up with thousandths. Okay. So that's one way. So we can do it again. I'm keeping the numbers small. Let's say I gave you 2.001 times 0.12. And let's say you lined it up with the decimal. You don't have to. Ignore the decimals. Ignore. Okay. So 2 times 1 is 2, 2 times 0, 2 times 0, 2 times 2. We're finished with that 2, so we're going to put a placeholder in. And now 1 times 1, 1 times 0, 1 times 0, 1 times 2. When we find this sum, we're done. But now we need to figure out what our final answer is going to be. So let's look at what we had. Our first number was 2 and, let's see, that's tenths, hundredths, thousandths. Times tenths, hundredths. Well, that's going to give me 1, 2, 3, 4, 5. That's going to give me 1/100,000. So I have to make sure that I have a place value that's going to take care of these thousandths and these hundredths. These thousandths and these hundredths. So I need 1, 2, 3, 4, 5 places after the 0, after the decimal. 1, 2, 3, 4, 5. I need to place the decimal so that I have tenths, hundredths, thousandths, 10,000, 100,000. So my final answer, that product would be 0 and 240,012 100,000ths. So a shortcut is to kind of count the placeholders. That'll tell you how many spaces after the decimal. When a student says, why? Well, that's because we're multiplying a number that is in the thousandths column by a number that's in the hundredths column. That produces an answer that's in the 100,000ths column. Okay. A second method is a little bit more, well, it's not exact because we can estimate to get an idea. Use estimation and logic. Estimation and logic. So for example, if I give you 8 and 2/10, and we want to multiply by 2 and 63/100, okay, there's a couple things we can do. We can say, all right, first of all, let's ignore the decimals. I'm thinking of a couple of ways to tell this. If I do this product, and I'm just going to help you out. If I take 82 and I multiply it by 263, I get a final answer of 21,566. And notice I'm not putting my commas in. Okay. Now, what I want to do is I want to use estimation. Now, what do I mean by that? Use the estimation to determine where the decimal goes. Where to place the decimal. Let me show you what I mean by that. I'm going to switch colors. If I write the same problem out, 8.2, and I'm multiplying by 2.63. We're going to estimate, do a little bit of rounding, okay? So I could either look at this as, well, this is close to the number 8 when I round. This is close to the number 3 when I round. So this should be close to an estimate of 24. So once we figured out what the estimate should do, now step 3, place the decimal point. You already have what the answer would be without having to worry about hundreds, thousands, things like that, like we did over here. But our answer should be close to 24. So where in this number of 21,566 should we place the decimal to have an answer close to 24? That would leave it after the 1 and before the 5, because 21 is close to 24. If I placed it after the first digit, that would only be 2. If I place it after the second digit, that's 21. After the third digit is 215. Well, that's way too large. So that's another way that we can figure out where the decimal goes using some estimation. Okay. That's pretty much it for multiplication. And then as far as division, we pretty much just use our standard traditional method for division. So let's take a look at division. In order for them to have success with division, they need to have had success in 3rd grade, knowing their multiplication tables. If we take a look at division, we pretty much only have a standard algorithm, a traditional standard practice. So for example, if I give you 15 and 345 thousandths divided by 15 hundredths. Well, one of the things we can do is make sure that that divisor needs to be whole. So in order to do that, we can always, I could write it this way. Maybe this will be easier. 15, 345. If I want to make that a whole number, that means this decimal needs to move 2 places to the right. So I need to multiply it by 2 powers of 10. Every time you multiply by 10, it gets larger, which means I'm actually only multiplying by the number 1. So I also need to do the same thing to the numerator. And so I'm going to move that over 2 places as well. So you might remember this from grammar school, from elementary school. We started with a divisor of 0.15 and a dividend of 15 and 345 thousandths. And you might remember your teacher going, well, move it 2 places to the right because we want it to be a whole number. Whatever you do to the inside or the outside, you also do to the inside. And now you know why. Because technically, what we've done is we just multiplied by 10 squared over 10 squared. And now I'm going to rewrite it, especially with the little ones. Rewrite it the first time. 1, 5, 3, 4. And now I can do the division in a standard algorithm. 15 goes into itself once. Bring down the place value of 3. 15 cannot go into 3. It's not big enough. Bring down the 4. Can go in twice. That gives me 30. Bring down the 5. It can go in 3 times. So we end up with our final quotient of 102 and 3/10. Okay. one more just to round it out. So again, if I have 4 and 736 thousandths divided by 2/10, it's easier to divide by a whole number. So I'm going to take that 2/10 and I'm going to multiply it by a power of 10. If I multiply and move this one place, 10 to the first, I multiply and move this one place. And then I would rewrite the number, especially with grammar school, elementary students, as 47. And now we can do that long division. 2 goes into 4 twice. Bring down the 7, goes in 3 times. Bring down the 3, goes in 6 times. Bring down the 6, goes in 8 times. 23 and 68 hundredths. But be prepared to ask why. Why do you move the decimal over? It all goes back to wanting to create a whole number. So since this was in the hundredths column, I needed to multiply by 100 in the denominator. On this one, we had 4.736 divided by 2/10. We need this to move. We need it to move over. It's only in the 10th column, so I only need to multiply by 10 to the first. And that's just multiplying by the number 1. So the value didn't change. The only thing that changed was the way the problem looks. All right, so that takes care of the operations, adding, subtracting, multiplying, and dividing. The next thing we want to take a look at is something called scientific notation. Using decimals. And so we use scientific notation to represent very, very small numbers and very, very large numbers. And scientific notation is used base 10. Scientific notation, again, is used to represent very, very large numbers or very, very small numbers. And scientific notation is written in 2 parts. You have your first part, you use your X to represent multiplication. And then we're going to represent it by multiplying by a power of 10. Okay, now this first part, this number A, is always a single digit whole number. I'll say it again, it's always a single digit whole number. 1, 2, 3, 4, all the way up to 9. Okay, so it rests between the number 0, but is less than 10. So it goes up to the number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this is always a power of 10. So for example, let's convert and write these numbers in scientific notation. So the first one is going to be 47,583,000. What's great about this is the digits don't change. The numbers themselves don't change. We just need to think, where can I place a decimal? Where in this number can I place a decimal so that the first part is between 0 and 10? Well, if you're thinking about that, it should be placed after the 4. So that means I'm going to have a 4, 7, 5, 8, 3. I can put the zeros, but I don't have to. And think about it this way. If I put this decimal right here, and now my first number is between 0 and 10, because it's 4.7. How many powers of 10 do I need in order to move this decimal back to where it started. So where did it start? I don't see a decimal at all, so that must mean it's down here at the very end after the ones column. So how far does it need to go? It needs to move 1, 2, 3, 4, 5, 6, 7 to the positive direction. It needs to move to the right. So I'm going to multiply by 7 tenths. Every time I multiply by 10, my decimal moves. Since I needed it to move 7 places, I just multiplied by 7 tenths. We'll do it again. Say I give you 30,782. The first decision is come up with a place value. Where do you want to put your decimal to make the number between 0 and 10? Well, it looks like it needs to go right here after the 3. So that means it's going to be 30782. I don't end in 0, so I don't have to worry about it. Decimal's going to go right here. How far to the right does it need to go to get it back to the original? 1, 2, 3, 4. Let's move, got to move 4 to the right. So look at that. 1, 2, 3, 4. Since I'm moving to the right, that's a positive 4. Those are large numbers. Let's look at small numbers. Let's say I gave you 0.0000813. Well, the first decision is where does the decimal go to make the first part a number between 0 and 10? It's going to have to go after the 8. So that means I have 813 with a decimal after the 8. Now it has 8 and. Now I need to know, wait a minute, where was the decimal originally? Well, it was originally way back here on the left side. So I need to go back 1, 2, 3, 4, 5 to the left. The left goes into the negative number system. And so this will end up being times 10. How many did I need? 1, 2, 3, 4, 5. In the negative direction, 5 places. Exactly the same as dividing by 10, dividing by 10, dividing by 10, dividing by 10, and dividing by 10 again. So if I gave you 0.814, that is going to be, let's see, decimal would go right here after the 8. So that's going to be 8 and 1400ths. But it's supposed to start in front of the 8, so it only has to go one place to the left. So then I'm only moving it and multiplying by 10 to the negative 1. Now let's go the other direction. Expand from scientific notation. So let's say I gave you 5 and 7100ths times 10 to the negative 4 power. Well, the numbers are the same, 571, but I've moved in the negative direction 4 places. So I started here, and I've moved 1, 2, 3, 4. 1. Now I have to insert 2, 3, 4. And so my final answer would be 0 and 1, 2, 3, 5, 7, 1. So since I have 10 to the negative power, that's the same as dividing by 10 each time. And that gives me moving my decimal in the negative direction. So if I have 3.0482 times 10 to the 9th, and 9 is a positive number, well, that means that's a positive. I'm going to multiply by 10 9 times. That means this has to move in the positive direction 9 spaces. So I still have the digits 30482, but I have to move 9 from where it was to where it will finish. It was here. 1, 2, 3, 4. Now I have to insert 5, 6, 7, 8, 9. I better count again. I was here after the 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I've moved it 9 to the right. And so I'm going to insert my commas. So 3,048,200,000. All right, so let's take this and calculate, simplify. Now notice that little x in scientific notation means multiplication. So I'm going to be able to use the commutative property and the associative property of multiplication. So let's say I give you, let's do this one. How about 4 times 10 to the 3rd times 7 times 10 to the 6th? Well, you'll notice there's no addition, no subtraction going on. It's all multiplication. So I'm going to rearrange these. And I'm going to put the whole number first. So I'm going to commute and associate. And then I'm going to put the powers of 10 together by commuting and grouping them. 4 times 7 is 28. Anytime we're multiplying and the bases are the same, we add exponents. And so you have 28 times 10 to the 9th. And then you have to ask yourself, is that correct? Well, no, because the first number is not between 0 and 10. So let's think about it. If I write this one in scientific notation, this would be 2.8 times 10 to the 1st. Because I'd multiply it 1 to the right. And then I still have this 10 to the 9th. I can combine these factors together because they're both powers of 10. So I end up with adding exponents, and I end up with 2.8 times 10 to the 10th power. Okay. Let's do another 1 or 2 of those. Let's try something else. Let's say I give you 1.2 times 10 to the negative 3 times 4 times 10 to the 6th power. Well, commuting and multiplying like factors, I'm going to take 1.2 and multiply by 4. Then I'm going to take 10 to the negative 3 and multiply by 10 to the 6th. 1.2 times 4, 4.8. 10 to the negative 3 times 10 to the 6th. Whenever you multiply, you add exponents. Negative 3 plus 6 gives us positive 3. And so I'm left with 4.8 times 10 to the third. And you need to put the little x in to represent multiplication on scientific notation. And division works the same way. Let's say I give you 5 times 10 to the sixth divided by 2 times 10 to the second. Well, again, this is one problem. There's no adding and subtracting. All of this is multiplication and division. They're all factors. So I'm going to separate it out. I'm going to first put my 5 over 2 together. Then I'm going to multiply the 10 to the sixth and the 10 to the second because those are common factors. Well, 5 divided by 2 is 2.5. Whenever we divide, we subtract exponents. So 6 minus 2, always working down, gives me 10 to the 4. Then you have to check to make sure your answer is in scientific notation. Okay. And then just to finalize, finish it up, let's review rounding for a minute. And check the book. The book has fantastic examples of estimation, of all of this, multiplication, division. I just want to go through rounding for a minute. Round 132 and 457 10,000ths. 0, 4, 5, 7. Let's go to the nearest hundredth. All right, I'm going to write this number down again. 132.0457. So what we need to do is find our hundredths column. Well, our hundredths is the number 4. And then look at the next number. If the number to the right of it is 5 or greater, then the 4 rounds up. Because remember, we have 10 digits, right? 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it's 0, 1, 2, 3, or 4, you don't change anything. But as soon as we go to 5, 6, 7, 8, or 9, you now have more on this side. So we're going to round it up. So this would round to 132.05. That's going to make it round up. Now, let's say I give you the same number. And this time I want you to go to the nearest 100. No TH. No TH. So the nearest 100, 10, 100. Well, look at how many 10s you have next to it. Since there's only 2 of them, remember that's 0, 1, 2. We haven't gotten to 5 yet. So it doesn't round down, it stays the same. So this would round to 1. The 3 stays the same, everything else goes to zeros. So it rounds to 130. It would round down from 132 to 130. Let's go to the nearest 10. 132, 0, 4, 5, 7. Uh-oh, that's what I just did. I'm so sorry. 1's 10s. This would be to the nearest 10. I apologize. So now let's go to the nearest 100. 1's, 10's, 100. So we look at the number 3. The one next to it. 3 of these are not enough to rebundle. And so this would stay the same and round down. So 132 round keeps that. Is this closer to 100 or to 200? Since this is less than 5 or less than 50, it's going to be closer to 100. And I don't really need all the rest of those. And then I do want to point out this one. If I ask you to go to the nearest 10th, because this has missed a lot. So I want to go over this with you. Notice where the 10th is located. The 10th is right here at 0. Okay. So we have to look at our next column. If I look at my next column, do I have enough to rebundle and carry it over into our 10th column? The answer is no, because I only have 4 of them. So this is going to stay the same. It's not going to round up. So the problem is, the most common error made is this goes to 132, but because it's being rounded to the 10th column, we have to have a digit in the 10th column. Since there's nothing there and 0 represents nothing, we still have to keep the 0 because it told us to round to the 10th column. If it's to any other column, 100, I don't need all those. If it's any other column, nearest 10th column, I don't need all those. But because we are rounding to the column and that 0 is in that column, we have to keep the 0. Okay, so that takes us to the end of section 7.2. And if you've got questions, please make sure you read the book and take a look at some of those videos that go with the section in your homework.